In the past 20 to 30 years, climate change has been an ongoing debate and argument that has seen neither side satisfied. Many skeptics argue that the result of greenhouse gas increase is exaggerated and dramatized, that there is no proof between the correlation of global weather patterns and carbon increase. But what if climate change has happened before, many times in fact? What if history is simply repeating itself? Will we be able to learn from the past? If we were to travel back in time 255 million years ago, the world and its surroundings we live in would be very different. The entire landmass that we are familiar with today were all once connected as one giant continent called Pangaea. This was the time of the Permian period and was home to a diversity of organisms as complex as those that live today. However, 251 million years ago, the great diversity of life that could be found in the Permian rock layer suddenly ceased to exist. It is estimated that around 90% of all life died out on the Permian-Triassic border. The puzzling question of what caused the largest extinction in the world's history has scientists speculating for decades. One key factor of the Permian extinction was the layout of the continent Pangaea itself. Because it was such a large landmass, it was extremely unstable. Most of it was arid desert with temperatures ranging from extreme highs in the day to extreme lows at night. Oceans were much deeper than today, and mountains even higher. These extremities created an unbalance in the biosphere, and it is thought to have set up the right conditions for extinction. Around 2,000 years before the main extinction, evidence has been found that there was a massive volcanic eruption in what is now Siberia. Known as the Siberian Traps, rather than an eruption from a volcano, this eruption was a series of surges caused by a mantle plume in which lava, ash, and toxic gases from the Earth's core spew up through fissures in the ground. The one in Siberia was massive and stretched for almost 2 million square kilometers. It wasn't so much the lava that affected life, but the gases CO and CO4 emitted from the surges that went on for about 1 million years. The gases increased global temperature, affecting even life on the other side of the world. Global temperatures were on the increase. This was not enough, however. The warming of the oceans caused by the eruptions is thought to have melted frozen gas hydrate bodies of methane-rich in C12. When this gas was released from the oceans, it further increased the global temperatures. The mechanism created positive feedback, meaning that as the temperature got higher, more methane was released, and that methane caused more temperature increase. From here, the biosphere spiraled out of control as global temperatures rose by 6 degrees. Not only were flora and fauna affected, but entire global systems. This pyramid represents the delicate balance that all life depends on. At its foundation are its key systems. In the Permian extinction, the heating of the oceans caused an upset in the ocean conveyor belt, which had an extreme effect on other weather throughout the globe. The runaway greenhouse destroyed the Earth's natural homeostasis mechanisms. This includes very important plant life. This had an effect on other trophic levels above it, including important keystone species. With the extinction of the keystone species that had a very important role in their ecosystem, it led to entire families being wiped out. In the Permian extinction, there was an entire system collapse. Taking this information, we see that there are certain similarities between the causes of the Permian extinction and our own climate change. Though we have not experienced an eruption like the Siberian Traps in our own history, we are gaining carbon dioxide in our atmosphere from another source, fossil fuels. The height of carbon dioxide on the Permian-Triassic boundary reached up to 3,314 ppm. That's about 8 times the amount of carbon dioxide in our current atmosphere. However, scientists have proved the correlation between increase in greenhouse and increase in global temperature. As we can see on this graph, atmospheric carbon dioxide has increased by 90 ppm in only the last 50 years. It is not so much the numbers, but the steep incline that has scientists worried. It is not only increasing, but increasing faster, as we see the gradient gets steeper. We know that at some point in Pangaea's temperature increase, the methane was melted from the depths of the ocean and released. This was when stopping greenhouse spiral became impossible. Currently, we have not reached that point. However, we have seen our poles, particularly the Arctic, begin to melt rapidly. The North Pole holds a high amount of methane gas trapped in the ice. So when we compare the end of the Permian period to today, we do see many similarities. At the end of the Permian period, the Siberian traps set off a CO2 increase. Much like this, our use of fossil fuels is also putting a very steady and high increase on the amount of CO2 in our atmosphere. In order to try and nullify the effect, the oceans try and absorb the CO2 and the heat, but in turn become more acidic. This is very bad for plankton and other crustaceans that rely on having a more alkaline type of water. Once these animals, such as plankton, are taken out of the marine food chain, it makes for very disastrous effects. We too have our own ocean acidification, though not exactly to the exact same extent. But we are experiencing with much more acidic oceans than we have in the past 100 years. With the warming of the oceans, the methane that was buried deep in the cold depths of the ocean is melted and is released. This is very bad as methane has double the effect of CO2 on the atmosphere, so once this was released, it created an extreme high in temperatures, raising the global temperatures by 6 degrees. Our methane is still frozen in the depths of the North Poles and also of our own oceans. It is not yet melted, but it is melting. In our North Pole, we are already experiencing severe melting of the polar ice caps. If this continues, the methane that is trapped in the ice will melt and be released into the atmosphere, so it is increasing. Once the temperatures rose and the gases became uncontrollable, the natural homeostasis of the globe was no longer able to control it. Organisms like trees in the ocean that naturally absorbs gases and balance out the atmosphere were no longer able to control the high amounts of gas and the high temperatures and began to die off. Our natural homeostasis mechanisms are still in place, but they are slowing down. So though we are not at the Permian rate yet, we are well on our way if nothing is done. In the Permian period, once this all happened, the greenhouse gases went into a positive feedback spiral. The more methane that was melted rose more temperatures, which melted more methane. Eventually, there was a breakdown in ecosystems and mass extinctions began. These 3 stages have not occurred yet, but if nothing is done, it is by learning from the past, it is very possible. Our global homeostasis is still in place, and if we do our best, we know that it is not too late. So by looking at these results, we see how crucial it is that scientists are able to reconstruct the past of our climate and the past of our Earth, because we can use it as something to avoid future problems like climate change. We already know the correlation between carbon dioxide and temperature, and the Permian extinction proves it. So from my research, my opinion is that yes, the events of the Permian extinction is a lesson for us today. Many argue that climate change happens naturally. It does happen naturally, but it happens at a much slower rate. So what we're doing is we're a catalyst for speeding it up, and from pumping CO2 into the atmosphere. So it doesn't give species and organisms time to adapt naturally. Instead, they're having to deal with these rapid changes, and this is when you get extinctions, which are already happening today, especially in our north and south poles and in those that rely on those cooler climates. But even if climate change happens to be some sort of silly ruse, by looking for sustainable and clean energy, we're still helping ourselves. So what's to debate? Off. Bye-bye.